I'm really, really pleased that we can welcome Haoyi, who's come from a long way. I think you're touring at the moment, aren't you, throughout the globe?
Yeah, I'm from Singapore, so it's like 16 hours. Pretty far.
It's pretty amazing. And he's going to speak to us about Mill, which is one of his many tools.
I'll turn this thing on. Hello? Hello? Yes. Okay. Okay. Hello, everyone. So this presentation is titled Solving Scala's Build Problem with Mill. About myself. Is there echo somewhere? Should I just turn it off and talk directly? Oh, yeah, people online. Okay. Hello? Yeah, I can hold that one, Zainab, if that one works. Actually, I suspect it might be my laptop. It's a Zoom. It's a Zoom thing. Audio. Okay, I think that should work. Sorry. Sorry. Okay. Okay. No more echo. Great. So about myself, I've been using Scala since 2012 or so. I started playing with it in college. Lots of open source projects. Many of you probably use one or more of these open source Scala projects. Probably not all of you use all of them, but you probably at least seen them. So things like JSON, file system, HTTP libraries, and so on. I've done work at Dropbox and Databricks. Right now I'm on sabbatical in between jobs, so just taking time to work on my open source projects. And I wrote the book Hands-on Scala Programming, which is a nice book if anyone wants to read it. The topic of this talk is Scala builds. So everyone uses SBT as a first approximation. Does anyone not use SBT for Scala? What do you use? Gradle, CLI, Mill, OVT. Oh, okay, that's Optimus build system, right? Yeah, I've heard cool things about that. Yeah, so most people will be using SBT, and I think SBT is one of the kind of big bugbears of Scala that scares off lots of people. When I started using Scala in 2012, I got scared. When I tried to introduce Scala at Dropbox in 2014, my colleagues got scared. And like, generally, you can do everything you want, but it's pretty scary. And this talk is just about, can we do something better than that? Like, after 10, 15 years, like, can we do better? Do we have the technology? So the first thing we'll talk about is, can Scala builds be easier? Like just as from first principles. And perhaps the problem with SBT is not the fact that it's not powerful enough or not flexible enough or not performant enough, because it actually is all these things if used correctly. The problem with SBT is usually that it is not easy to make it do what you want. It's very easy to not be performant. It's very easy to not be able to figure out how to make it do what it should be able to do. And Scala CLI works great for smaller projects, but many larger projects, you always end up with 5 modules, 15 modules, 5 test suites, 6 integration test suites, 1 end-to-end test suite. And in many real-world code bases, Scala CLI doesn't really suffice, even though it's very good for getting started. So let's talk about SBT a bit more. Just running SBT is something you need to teach people, which is very surprising. Like you open up like Python, you type Python, something like command line, it works. You open up NPM, you type NPM, something, it works. You open up SBT, type SBT something, and like 2 days later, your colleague tells you, hey, this is actually really slow. It's much faster if you do this other way, where you open up SBT first and then you type things into SBT. And although it's not rocket science, like we all know how to do this, it's additional overhead that you need to put in your brain. Your brain's already trying to do other things, like do your actual code or actual project. Even this is another example that came up recently. I took an example SBT build and I wanted to turn on test parallelism. It took me 2 hours and I had to ask for help on Discord after because I couldn't figure it out. And ChatGPT also couldn't figure it out. Yeah, there's a lot of subtlety, like if you turn on parallel execution, it works, but it doesn't work with fork unless you turn test fork parallel, but it might also still not work because you have concurrency restrictions. You have 2 different concurrency restrictions, you set the right one. There's also test grouping, where if you turn test grouping the wrong way, your test might get much slower because test grouping spawns more separate JVMs, which might create more overhead. And it's a lot of work that is actually very hard to get right. Even for a simple thing like I want to turn on, make my test run in parallel. Another example I'm going to look at is ID support. So let me pull up a good example SBT build. So I'm going to use a Gatling project. Gatling is not my project, and I'm just using it as an example. It's kind of a medium-sized SBT project with a good number of submodules you can see here, and a non-trivial build. So IntelliJ does have IDE support, but when you try and jump around, some things work, some things don't. For example, local definitions within your SBT build will work. This stuff works, common dependencies works. The other things don't. For example, let's say I'm a new developer maybe, and I don't know what library dependencies is. So this is a bit of a straw man, you all know what it does. But hypothetically, let's say you're using some plugin and you don't know what it does, or the build is misbehaving, you want to see what's actually going on in there so you can understand a bit better why it's not behaving as you expect. In an application code, you'd want to just jump around. So if I open up like Gatling JDBC, some random file in here, I can expect to be able to jump to any identifier in this file and get useful information. In-memory feeder source, what is that? No docs? Don't worry, you can jump to it. Index sequence, I don't know what that is. Maybe I just learned Scala, I can jump to that too. And this is experience you're used to in the IDE. And it doesn't really work in SBT where you jump to library dependencies, and it kind of gives you these stubs. And so this is decompiled code. You can make it download sources, it'll give you a bit more. I think I couldn't get it to work just now. And but even if you did have the sources, which I'm going to show you now, let's go to the file on GitHub. Sorry, library dependencies. So even if you did have the sources for library dependencies, you get a bit more documentation, which is nice, but you can't really figure out who's setting it or what the value is, which is what we actually want, right? Like, I don't care that the val is defined here. I care where did the value come from. In this case, for SBT, the val is not the value is just kind of a global stub. The last thing you're going to look at is kind of the extensibility story. So SBT has a lot of plugins, which is great. SBT often needs a lot of plugins, which is not so great. So often when you want to set up a new Scala project, like of course you want to use some kind of auto formatter, of course you want auto fixing, of course you want this and that. And with SBT, you can do all of this, but it's non-trivial. You end up doing this kind of grand tour of the Scala open source ecosystem. You can see this like the list of Avengers here who've all contributed something to make the project work. And while it's a great example of open source, it's also a lot more troublesome to get started than you'd expect. You expect to download the tool and be able to start coding, right? You don't want to start configuring your build plugin and try to judge GitHub projects based on how many stars they have, because that's not what you're paid for. Apart from plugins, another example I'm going to look at is, let's say there's no plugin to do what you want. Let's say you need to configure your build yourself. This is kind of a straw man example. Count the lines of code in a project and save it to line count to TXT to use at runtime. But it's representative of the many weird and arbitrary things that you're not having to do in real projects, right? Maybe you need a custom bill of materials for security scanning. Maybe you need a custom deployment artifact for some weird internal infrastructure you're deploying to, or something like that. And for SBT, while this is not rocket science, it's again non-trivial. And I dare say most of you will not be able to bang this out kind of without having to spend time crunching through documentation or ChatGPT. And I personally was not able to bang this out without ChatGPT's help, even though I'd used SBT for many years. So if you look at it, the actual business, or not business logic, the build logic here that we care about is not complicated. I have some documentation as a string. I want to read the lines on the source files and sum them up and write it to a file. But all the other stuff that's kind of weird pseudo Scala, that's actually Scala, but also not really Scala because you never actually write Scala like this in your real projects, that's the stuff that you'll have trouble with. Like, none of you will have problems reading lines and writing to a file. That's easy. But it's all the other SBT stuff that is a challenge. So that's kind of the basic problem statement here, that Scala builds or SBT, while it can technically do everything you want and actually technically be very performant if used correctly and very extensible, it often is much harder to get started with than you would like it to be. And for this talk, we're going to look at Mill, which is one potential alternative. So what is Mill? So Mill is an open source JVM build tool. It's not a new project. It's been around for coming on 8 years now. And originally it started for Scala, but now it supports other JVM languages and some Python, Android, JavaScript, other tools chains as well. And it mostly does the same things as the other build tools, but just tries to be better, and you'll see in a moment. It's moderately widely used, not as widely used as SBT, but all of you probably use Corsair, maybe transitively through SBT or Bazel or Gradle or whatever. All of you use Scala CLI at some point. Maybe use some of my own projects. All of these are built using Mill and have been built using Mill for a while. Just to say that it's not like a new project. It's kind of out there, quite heavily used. Docs are here if anyone wants to look more, mill-build.org. And a simple mill build looks something like this. I have imports, package declaration, say object foo extends Scala module. So foo, I have a Scala module in the foo subfolder. Define a Scala version, some dependencies using the Gradle format, kind of. And I have a test suite with its own dependencies and test framework. So this, nothing special. I can compile, run, test, assembly, take the assembly, run it later, all kind of bog standard build tool stuff. A more involved example here is a small HTTP4S application. I don't know if anyone here uses HTTP4S. So this is not, again, not rocket science, just showing you it can be done. So the example is over here. I can do mill -- watch. I think I need to say run background. And then this should run it. Let me give myself a new window. This is what localhost 8084. So this is my running HB4S app. I can make edits to it. For example, if I want to change some of the Scala text templates, so instead of saying to do's, I want to say hello world. You see it reloads automatically. Now it says hello world. CSS a bit messed up, but never mind. Make it big. Oh, it's still messed up. Never mind. Yeah. But yeah, so this is showing you that you can run these slightly more involved apps using Mill. It's not just for hello world. The question people often ask after that is, okay, what else can you run? And the answer is mostly everything that you'd want to do in your JVM project, whether Scala, Java, Kotlin, whatever. Here I've showed all the Scala versions. So we have built-in support for auto format, auto fix, binary compatibility, coverage, circular import detection. We have actually all the same for Java and Kotlin. So we have Palantir format instead of Scala format, we have KT format instead of Palantir format, and so on. And it's kind of very convenient. Like we already saw that any mill build already is executable assembly is built in, because of course you want to take your code and compile it to something you can run later, right? So I want to do it, you want to do it, so we just made mill do it, so we don't need to go and hunt down the right plugin to make it do it for you. And all the different test frameworks, publishing formats, and so on. So that's kind of a lightning glance at what mill is. Next is maybe why is mill interesting? And the reason I would say mill is interesting is that it tries to solve the problems we saw earlier, not in making mill like better at the extreme, but making mill easier to get to what's a good experience or good outcome as a user of your build. So for example, if you look at performance, we took the Gatling codebase as an example again. So Gatling is not my project, it's not built using mill normally, but we ported it as a case study just to have something to compare as a realistic project that's not Hello World. So 20 sub-projects, 80K lines, not a small project. We got all tests passing in both builds. So the mill build is complete enough to have all the flags and compiler flags and JVM flags pass. And we did some benchmarks. And I guess all of you already know that SBT actually has two performance profiles depending how you use it. If you use it cold, which is an easy and obvious way, it's really slow. If you use it hot, which is a bit more finicky, like you need to make sure you remember to reload and control C need to go back in and all that, it's much faster. And mill, you use it cold, and it basically does the same thing as SBT you are doing, but mill does it for you. So we create the server in the background that's long running. If you kill it, we'll recreate it for you. If the config changes, we'll reload it for you. And none of this is like special. It's just we do it for you, so you don't need to do it yourself. And it takes some overhead off the programmer who's already struggling with whatever business problem that they're dealing with. Compile is not the only thing that people deal with. We already saw watch and rerun earlier. That's kind of handy. Mill's test parallelism is a single flag that generally just works. Like we kind of spend a lot of time trying to make it self-tuning, so it works for fast tests, slow tests, many tests, few tests, and it generally works without needing to fiddle with any concrete number. Just say parallel, and it becomes parallel. Selective test execution is really handy in big code bases where, yeah, you git diff something, and what's affected by this diff? Probably not everything, probably some subset of the monorepo or big code base. And with Mill, you can actually ask Mill, hey, tell me a list of modules that are affected. Tell me how these modules are affected. Gives you this JSON tree of who affected who affected who affected who. And when you run it, it'll only run the affected tasks or affected modules test suites. So this is very handy for big code bases where you're often not changing the whole thing all the time. Incremental assembly is another neat trick where the first time you create a huge 200 megabyte Spark Submit assembly may take 20 seconds. But the second time you create a mill, it takes 1 second, because zip jars are zip files, assembly jars are just zip files, and zip files can be updated incrementally very efficiently. The JVM even provides functionality for it in java.util.filesystem, the zip file system. So mill just uses it. So the second time you create the jar, we compile the files, and we just splice in the files that changed, so you don't need to recreate the whole thing with all the third-party dependencies from scratch. So it takes 1 second instead of 20-something. The Chrome profile is a handy thing. So every mill build generates a profile like this. I can show you. So let's go back to Gatling from command line, and I'm just going to run mill underscore clean and mill double underscore dot compile. Let me make this bigger so you can see it. So while this is running, one thing that most of you probably don't know is that every Chrome browser, okay, let me see. I need to click a button to do it now. Okay, let's try that again. So every Chrome browser comes with a built-in profile visualizer. Most of you probably don't know this, but it does, and all of you already have Chrome installed. So mill generates this Chrome profile file for every command you run that you just drop into Chrome and see where my time is going. So in this case, all going to that one compile step. Let's try again. So it is HTTP4S. I need to open the Gatling code base. This is my mill Gatling code base, and I drop this in. And just like that, voila, you can see where my time in my Gatling compile all is going. So people often think build tools are opaque and confusing, and they are, because they don't tell you the things they know. Your build tool knows where the time is being spent. And mill just takes this information and puts it in a manner that's very easy for you to get at. Like Gradle has the same information. You just need to go pay Gradle Enterprise to get the Gradle self-hosted server that you deploy in your infrastructure and upload a build scan to it, then go to your internal website, get this information. Mill, you just have a JSON file you dump into Chrome. You all have Chrome, and you get a nice visualization of what's taking time and some ideas of what you can do. Like, for example, does HTTP test compile in this corner really need to depend on the whole Gatling core test? Or can it depend on some test utils submodule that will compile much faster, letting all the stuff on the far right move to the left and giving us a shorter wall clock time? Like, you don't need to know anything about Gatling or anything about mill to have ideas how to improve your build. And this is one of the things that mill makes very easy. So that's the performance angle. So again, nothing I showed here is rocket science. It's all pretty standard, like JSON here, zip file there. We start this process here. Mill just does it for you and makes it easy enough that you can benefit. So although in theory, SBT can do all these things, Gradle can definitely do all these things, it's troublesome enough you're probably not going to bother, and you kind of get the worst experience just by default. The next thing I'm going to look at is ID support. So earlier we looked at the Gatling Gradle code base, Gatling SBT code base, and saw the ID support works sometimes and fails other times. Let's look at the mill equivalent code base. So over here on the left and over here on the right, I'm going to make this bigger, we have the config for the Gatling core module in mill on the left and SBT on the right. So the first thing you realize is that it actually looks very similar, and they all have the same information, which is expected. So both of them will have some dependencies on other modules. Gatling core depends on netutil, quicklens, commons, JSON path. The test suites depend on each other as well, which is the syntax is a bit different, but it means the same thing. They both have some dependencies on libraries. Mill calls it IV deps, SB calls it library deps. Again, it's the same meaning. But it's not like we're doing some magic here. It's like we are just taking the same information that SBT has and porting it to mill. So what's interesting is when you start digging in, where SBT you jump to library deps, you get stubs. Mill works by override, so IntelliJ says there's an override here. I can go Java module base and see IV deps. I can see the default value here. I can see where IV deps is being used, and so on. I can kind of trace IV deps through my build. I can see IV deps is used in this big chunk of code, which is use Corsair project 0 is in Corsair project use transitive Corsair projects. And this way you can kind of trace through your build and understand what is going on. It's not just this is the value and this is the documentation, but who's using it? Who is it using? Where do these values come and where do they go? And these are things that you're already used to doing every day in your application code. Mill lets you do it in your build code. For example, let's say I go here and want to add more config. Let's say I override def like fork and so you get autocomplete, you get documentation when you override things. You can jump to the override, let's say run module. I can see where forkenv is being used. Forkenv is used in the runner. The runner is a helper that gets used in run background and run forked. Run fork gets used in run main and run. And just like that, we can see how the value we set, not just what's documented in, but how does it actually go through our build and end up in the things we care about? Like how does forkenv affect our running? And this is how. And we can go the other way as well. For example, run fork task requires final main class. What's this? I don't know. Well, jump to it. Final main class is either optional, either it's success or failure. Jump to this final main class optional. It's either the main class that you configured, or if you didn't configure, it's all local main classes. What's all local main classes? Well, you can jump to that. I want to jump to this one. See, all local main classes use the local run class path, and I call this a discover main class, either sub-process or in-memory in-processing on it. And you can go arbitrarily deep and try to explore what your project is doing in a very kind of visceral level, the same way you do in any application code base. And notably, what you cannot do in build tools like SBT, but also Gradle or Maven or other build tools. You can't really do this kind of exploration, even though they technically have IDE support. Okay, here's a thing. So the last area I'm going to look at here is the extensibility story. So the first thing to talk about is Mill has a lot more things built in. So SBT could do it, it doesn't, we did. So we built in native packager support. So you want JLink, you want JPackage, you want assembly jars, you want Graal native images, we have it built in, very convenient. Annoying for us to implement, but very convenient for users, which are also us to use. JMH support, we wanted that, so we put it in. Jupyter, JUnit 5, most popular testing framework in the world on the JVM, we best build that in. There are still third-party plugins. For example, Scala Fix is still a third-party plugin by Joan. But in general, you can go much further with Mill before you need to start assembling a plugin team. And that's very convenient for getting started. The next thing is that when you don't have plugins, when you're going to do something that's really, truly special, Mill makes it much easier for you to do so without needing to become like a plugin author or plugin expert. So to illustrate, I'm going to come back to my code. Let me open up sorry, I need to pull up the right folder here, custom Scala. Okay, let it import a minute. Okay, so over here, I have like a small like hello world Scala build. This is even more minimal than the one we saw earlier. There are no dependencies. There's no test suite, just really hello world with the Scala version. That's the minimal thing you provide. And there's a small like Java code base that reads a line count.txt from disk. And this is kind of going to the example we saw earlier. What if we want to generate a line count.txt file as part of our build? Again, synthetic, contrived, but no less arbitrary than many of the other arbitrary things you actually have to do for your real projects. So in Mill, generating a line count.txt or custom task in general is simply as saying def line count equals task. This is just a normal Scala def. There's this task wrapper here, does a bit of magic, but hopefully not too confusing. And I can start calling other methods. For example, I want to see what source files I can look at. Do I want resources, all sources, doc sources, maybe an all source files? It says all individual source files fed into the Zinc compiler. Let's make this a bit bigger so you all can see. Call the method, map it to file, goes to, let's say, file.path, os.read.lines, .length.sum. And that's our custom task. Maybe we want some Scala doc, right? Let me say like all lines of code in this project, sub-project. So now I can do mill show foo.line count. Is this big enough for you guys at the back? Should I make it bigger? Okay, good enough. Yeah, so line count 17, that's great. That's a number of lines of code in this small example. I can do mill inspect foo.line count, not so different from SBT. You can see that we very conveniently capture the Scala doc for you, so you don't need to put in a string. So IntelliJ knows Scala doc, IntelliJ doesn't know strings. So we put in Scala doc, IntelliJ knows, but we also capture it so that the command line knows. We have the foo.line count name, file name, line number, inputs we are shown. So just like 4 lines of code, maybe 5 if you include the Scala doc, and we have a custom task. So we haven't integrated into our resources yet, and let me show you how that's done. You say override def resources. You can, if you don't know what you want to override, again, ID helps a lot. So let's say I want these resources, again, as a task. And I want to write to this task, the destination folder. I'll explain in a moment, line count.txt. And I'm going to say the line count as a string. And I'm going to return the super resources. You already know what super means, plus reference to my destination folder. So what's this destination folder? So one big problem in builds is that they're very side effecting, right? You have files, you're on disk. Everyone's reading and writing your files. I'm deleting files, you're creating files. I might delete your file, you get angry, I get confused, all sorts of bad things happen. So Mill cannot stop you from dealing with files, but what Mill can do is say, every task gets its own folder to put stuff in. No one else will put stuff there, and no one else will delete stuff from there. So when I write stuff to this task destination folder, it's almost like an immutable value. It's technically on disk, it's technically I/O, but no one else is going to race with me or conflict with me or delete me or override me. It's basically a pure value. So now when I say mill show foo.resources, you can see that it has two values. One is the normal foo/resource folder. One is this out foo/resources.dest folder. So this is a .destination folder that we saw as task.dest here. If I look at what's in here, line count.txt, you can see that the contents is 17. And now if I do mill foo.run, we can see that it's able to load this resource at runtime and print it out. So again, like, this is not rocket science, but hopefully this is somewhat easier than the example we saw earlier with SBT, and maybe more importantly, more familiar. Like, this code looks not too different from the code you're writing day to day. You have objects that extend things, you define methods that call other methods, you maybe override things and call super. You already learned that 10 years ago in Java 101. You know how that works. And that's really all there is to it. There's a bit of magic, but hopefully you don't need to deal with that kind of explicitly. Let's take this one step further. Let's say instead of using line count as a text file, I want a HTML file. Again, arbitrary and weird, but let's run with it. So with Mill, you cannot just import HTML templating libraries directly because Mill doesn't ship with HTML templating libraries. It's a build tool. But you can import them indirectly using import IB syntax that comes from the Ammonite REPL. And you can say com.ly Haoyi, Scala tags. Let me see what version I use in the example, 0.0.12.0. And I just reload my IntelliJ. And voila, so now we can see Scala tags is available on my libraries path in IntelliJ. I can jump to it and explore it like any other library. And I can say that def HTML snippet equals task. Let's say I want a div with a h1 of like line count. Sorry, I need to put underscore here to import all the helpers. And a paragraph with the line count value as a string rendered. And maybe instead of putting a line count in the file, I put HTML snippet. Now I do foo.run. You'll see that now renders HTML. So this is kind of one of the interesting things about Mill, where like, all of you already know how to write Scala code. All of you already know how to write JVM libraries. In this case, a Scala library, but we use Java libraries or other libraries as well. So when you want to do something with Mill, you can just write the code and use the library you want to do what you want. So in this case, there is no Mill line count plugin. There is no Mill exec something bash script plugin. There is no Mill HTML generation Scala tags plugin. But we don't need one because it's so easy to just customize Mill using normal Scala methods, using normal Scala libraries to do exactly what you want without being beholden to some half-maintained GitHub project that you found 5 years ago. So that's the extensibility angle. Yeah, so why is Mill interesting? The performance, I think, is easier to get. A lot of things built in. The understandability with IDs and exploration, I think, is very nice. It's not just a black box where you configure keys, but you actually can explore the logic of your build to try and figure out what's going on, especially when it misbehaves. And extensibility, where when you actually do need to configure something, it's much easier to just say def something, do the thing, and it gets done for you without having to fiddle with plugins. So that's all great. Why doesn't everyone else have this, right? Like, this seems like nice things to have. So I think the reason why everyone else doesn't have this is that Mill's built on some interesting ideas that most other build tools do not have. And I listed 3 of them here. Let's go through them in turn. First is like the idea that build graphs are pure functional programs. So who here likes pure functional programming? Okay, all of you do. So you look at what build tools do. It's all in this format. Do thing to inputs and inputs to make output. In Mill, it's spelled a bit differently. There's this task wrapper, def, curly braces, whatever, but it's the same thing, right? Do something to inputs to make the outputs. And what does this apply to? This applies to basically everything you do in your build. Like, your dependencies, you resolve dependencies to make jars, and you have Maven Central there, but did you know Maven Central is an immutable data store? You cannot update or delete things from Maven Central, so it's just like an immutable part of your pure functional program. You code gen your IDL files to make generate source files. You compile your source files plus dependencies to make class files and blah, blah, blah. They're all pure functions. And again, we have some stars there, like you're writing files to disk, you're reading files off disk. But if we manage that carefully, you can kind of treat those as pure functions as well if you don't let tasks delete other task files, for example. So on the left, we see the pure functional line count. On the right, you see something you may see in Gradle or Make or some other build tool or Bazel, where you have on the right, you'd just be reading things off disk, you'd write things to disk, and that's kind of the more common way that build tools let you define tasks. On the left, you read values that are returned by other functions, and you return the value that you compute. You don't just like put it on side effect some random place. And this actually has very important consequences, right? Like each task only reads its inputs, returns its outputs, can be files, there's a star there. But it means that we know where tasks are reading and writing from. We know which tasks depend on each other because they call each other. And we can use these dependencies and of pure functions to parallelize, cache, and schedule your tasks in a way that you can't do with imperative tasks. Like over here, what are you going to do? Are you going to do some bytecode analysis to figure out which strings are files on disk and figure out which tasks depend on each other? People actually do that in Python land, in Make land, and it does work, but it's very fragile, it's very complicated, and it's very difficult. Whereas the pure functions that we have on the left, we basically get all this stuff for free. We know what the shape of the graph looks like, who's calling who. We can run them all in parallel because they're pure, with an asterisk. We can cache them because they're pure. And Mill can do all of this on your behalf because you don't have a say in what's cached or what's parallelized. Like you say, give your build logic here, and Mill does all the rest. And the last thing here is the jump to definition thus is useful. And you can see this here, right? So SBT, although it's nominally Scala, the programming model is actually a global mutable variable. So when I define val unmanaged source directories, there's no value there, there's no computation there, it's a variable. And someone somewhere is going to say colon equals and set it to a value. Someone else somewhere is going to say colon equals, set it to another value. Someone's going to say plus plus equals. And it's going to all this global mutable state means when you jump to unmanaged source directories, you get nothing useful. You don't know who's setting it, who's getting it. It's just empty, which is very common working with global mutable variables. If you use Java, you often jump to these variables and have no clue what's going on. Whereas it's Mill, because it's functional, we return the values and override values rather than just mutating them. You see all source files can jump to the definition. Here's how it's computed. All sources jump, find source files, curious about that jump. And so this pure functional nature actually does make a concrete improvement in your day-to-day life. It's not just like, oh, I'm doing it because I'm being elegant and pure. Actually, hey, it makes my jump to definition work and lets me explore my build graph because of the pure functional nature of my build. So that's the first idea. Build graphs are pure functional program. The second idea is the opposite. That Mill is all about object-oriented builds. Like who here loves object-oriented programming? Smaller number. So you see object full extends Java module. Like this is something that everyone should know. This is an object that extends a superclass or trait or abstract class, whatever, same thing. And when an object extends a class, you get these methods, right? These methods call each other. Data flow flows through the methods. Like sources gets called by compile, gets called by class path. Slightly simplified in this diagram on the top right. But the basic idea behind Mill is that your objects are your subprojects and your tasks are your methods. And you already know how objects and methods work, including classes, override, super. So you already know how all this stuff hangs together. So when I say def line count, that calls all source files here. When I say override def resources, that calls super resources, I don't need to teach you anything. You know how this stuff will affect the build. You know how it will end up splicing the kind of call graph within my methods. So line count gets called sources, resources called line count, super gets called, assembly calls a new override. You already know how all that stuff works because that's Java 101. And once you have this graph, you can start doing interesting things with it. So once you have the graph, we can say, hey, compile and line counter don't depend on each other. We can run them in parallel. And because they're pure, we know that we can run them in parallel without them stomping over each other. We know that assembly depends on them both, so assembly has to run later. And you don't need to tell Mill that. Mill knows it by default. Mill can give the different tasks files on disk to cache things. So for example, foo.linecount gets just out foo linecount.json file. Foo.compile gets out foo compile.json for metadata, and out foo compile.desc for the files it outputs, which many task output files. And other tasks like assembly will all be assigned different paths, so they will never collide. Lastly, for invalidation, if someone touches my resource folder, which is now super resources because I overrode it, Mill can just do a breadth-first search and say, okay, resources needs to update, assembly needs to update, line count and compile do not need to update. And when I update assembly, I know where to delete the files because I know that the files created and any caches are in assembly.json and assembly.dest. So Mill can just do this invalidation for you, wipe out the files for you in a safe and correct way without you having to do anything. And what's most interesting here is that you look at the build config on the left. There's no code here related to dependency tracking, parallelism, caching, anything at all. You don't see like file function.cache from SVT. You don't see computing cache keys, reading, writing files with cache keys. You don't see locks, futures, threads, semaphores, any of the concurrency model things. All of that's kind of hidden behind the scenes. And what you have here is basically pure build logic. It's pure in multiple ways. It's pure in that there's no side effects. It's a pure function, but it's pure in that we don't have all these other concerns mixed in where, oh, this task happens to spawn a bunch of threads because it needs parallelism, or this task needs to take a lock because you need to make sure no one else is going to screw up its files. So we have pure build logic here, and Mill does everything else for you. So that's kind of the benefit of this object-oriented builds based on objects and methods rather than tasks and other kinds of abstractions. The last thing we're going to look at is this idea of a direct style DSL. So who here has heard of direct style Scala? So Mill is an example of direct style Scala. Look at the code on the left. Who here knows that there's an effect system involved? So a few of you, there is an effect system. Like if I look at my signature, there's this T thing here. If you see here, is wrapped. There's an applicative effect system. It's not monadic. So applicatives have a bit of different trade-offs from monads that you may be more used to. But it's an effect system that is hidden so well that all of you who are good at Scala didn't even know there's an effect system here. You just call methods, and they generally do what you want 99% of the time. 1% you have to fiddle with it, but 99% you do what you want. And can more or less pretend it's like a Java 101 project, and it just works. This is in contrast to SBT, where although it's technically Scala, it looks totally different from any Scala you see in any production code base. And it's very explicit where the effect system is, right? Like I have a lifted version of task that's not a method. I have variables I call lazy val rather than var because they look different and they're different. Mill, we kind of hide it, and we hide it well enough that most people don't notice and don't need to notice. And one way we look at this is, why is SBT so hard? Well, one reason why SBT is so hard is that it's really a two-stage program, like many effect systems are, where you construct your program first and you run it later. Well, in SBT, the constructing a program part is actually quite easy, right? It's lazy vals, you're calling methods, you have some operators, that's fine. You have some blocks. And both humans and as well as IDs are IntelliJ have no problem managing all this stuff. Like we can jump from line count here to line count here, and that's helpful to some extent. But what SBT doesn't have good support for in IntelliJ and in humans is all the stage 2 stuff. Like, you know what lexical scoping is, right? Do you know what the 4-dimensional XPT hypermatrix looks like? I'm not a 4-dimensional person. I have trouble visualizing tesseracts in my head, so I have problems with this. You know how traits work, including things like stackable traits, inheritance, all that, multiple inheritance. Do you know how settings lists work? Like if you order settings lists differently, how it works? Well, you don't know, and IntelliJ doesn't know, so IntelliJ isn't able to jump to find things where they got overridden by settings lists because IntelliJ doesn't understand settings lists. Settings lists are not Scala, they are this SPT thing. But IntelliJ does know traits, so IntelliJ can jump around that. So what Mill does is Mill works very hard and jumps through a lot of hoops to try to squeeze all the logic into your first phase of your program. And I said it's like 99%, 1% of the time there'll be some edge case you have to deal with. But most of the time it just works. Like Scala doc is doc strings. Like SBT has a separate string that IntelliJ doesn't understand, and Mill just uses doc strings. And we had to have a compiler plugin that will scrape your Scala doc and put in the annotation, fetch it using runtime reflection. But you don't need to know that. We just did all that for you. And you just know that when you look at something in IntelliJ, you get Scala doc, and you can use it in the command line as well. Objects are tasks, methods are tasks, objects are modules. The object tree is a module tree, overrides and super, you know how that works in any Java application, Scala application, so you know how that works in Mill. IntelliJ knows how that works in Mill, that's how you could jump around earlier. We didn't need to teach IntelliJ much about Mill in order to get this support. There's no Mill IntelliJ plugin. Just uses the normal Scala plugin, and this fiction of it being real Scala code is correct enough that it works like 99% of the time. So these are the key ideas I think are so interesting that make Mill able to provide a better experience, but also makes it difficult for other build tools to provide this experience, because these are not like shallow like features someone implements as a pull request. These are really architectural foundations of what makes Mill tick, how it's architected, how the user experience is designed, how the data model and the programming model works. So the combination of pure functional programs and object-oriented programs plus this direct style magic to hide all the effect system stuff for you, that is what makes Mill so special. So here's the last slide. I guess the summary of this whole talk is, if you're using SBT and you're not happy with it, some of you may be happy, but if you're not happy with it, you should definitely give Mill a try. It is pretty mature. It's not as big as SBT in terms of usage, but it comes with a lot of very interesting ideas that have really concrete improvements in use cases. Not just interesting ideas for the sake of it, but interesting ideas that give you ID support, interesting ideas that give you performance and caching and parallelism, all for free, and all sorts of things like that. So the documentation's at millbuild.org. There's a GitHub page if you have problems, and there's my email here if you want to contact me later. And that's the last slide. I'm done. Thank you.
Any questions?
So my most hated thing in this life is Scala 2.12. And SBT is obviously, everything is interacting with Scala 2.12. As far as I could see there, you're using Scala 2.13 in your definitions. Is there Scala 3 support?
There will be in May, which is next month. Yeah. we have the branch already on Scala 3. What's his name? Jamie from the Scala Center helped us port it. And yeah, basically everything works. It's currently internal dog fooding. I think in 2 weeks' time, it will become external dog fooding. And then after a month or so, it may become a final release. But yeah, so it will be Scala 3. And at some point, we can remove all the curly braces. Yeah.
I had another question, which was, so as a library maintainer, one of my big draws to SBT is something like SBT type level, which simplified my entire existence. Is there scope for a mill type level kind of ecosystem that could do all of those same things with the additional simplicity?
There is. So I don't think there is one now, but if you'd like to start one of the things about Mill is that this thing we see here is very easy to program, also applies to plugin authors. So I could literally take this, convert object to trait, push it to Maven Central, and there's a plugin. People can download it and start using it. So it's very easy to write Mill plugins, much more so than SBT plugins. There's instructions on the doc site. You need to set up some dependencies and maybe some integration testing, but that's all documented. But yeah, if you want to configure your Mill build with standard plugins across the ecosystem, across the community, you can set up your own. The community is smaller than SBT, so there will be fewer built in or on the third party, but you can set it up yourself and it shouldn't be too difficult. Yeah, and if you do send us a pull request, put it on documentation site. There's like a big list of them over here. Let me pull it up for you. Here's millbuild.org. Third-party plugins. Yeah, this list is not as big as SBT's list, but there's a whole bunch of them, and you can add it to this list if you have interesting things to share.
Cool.
Yeah.
Thanks.
I have a question that kind of leads nicely off that one, actually. It's about the maintenance experience. So I feel like one of the things you talked about quite a lot is to have this very strong principled approach to user experience and how people extend it. So how do you manage the challenge of like making sure that the things other people contribute or the plugins that they're adding also fit not just like documenting it and this stuff, but like the spirit of good design of the tool? Yeah,
it's a challenge. Not all the contributions are great, and even our own sometimes are not as high quality as you'd like. So we have been putting in effort in kind of guardrails. So for example, if you try and outside of a task, just like write to a random file, is allowed in Scala, we will block it. If inside a task, you try and write to a file they're not meant to write to, like there's not in the destination folder, we'll also block it. You can work around the block, of course. This is like a best effort thing, but we do try to put in some guardrails to say, like, if you're doing something bad, you have to put in effort to do the bad thing. Yeah, and I guess a lot of it is purely on documentation. Hopefully people who read the docs, which will all be in basically the correct style, And most of them will be Scala developers who are also used to just returning stuff versus scribbling over the file system. Hopefully, it will mostly fall into place. But yeah, it's a challenge. I've had pull requests where I've had to get them to kind of overhaul it because they were used to a more mutable, global mutable style, and we had to change that. Yeah.
Yeah, that makes sense. Yeah, to be clear, I meant it more in this positive sense because I think a lot of people can use mentorship on that sort of thing or guidance, and that sometimes when it first comes in, there's room to grow there for sure.
Yeah, I mean, one thing that helps is that we have a very thorough example base of like basically the same thing in every language. So we're gonna do testing in Kotlin, we have it here. We're gonna do linting in Scala, we have it here. And all of these hopefully give you some idea of what a mill build is meant to look like. So anyone who reads the documentation should have a decent idea of how it's meant to go. And also for more advanced cases, like we have example TypeScript toolchain here implemented from first principles. So someone who wants to know like, hey, what's it like actually being the guy implementing the toolchain rather than the guy using the toolchain? We have kind of a best practice of what it should look like. Yeah.
Yeah, thanks.
Okay. Diego?
Thank you very much. Just a quick question. Does Mill also require like SBT and JVM itself to run? Is itself a JVM program, the Mill tool?
The JVM is optional in that we will download one if necessary. Unless you are on Windows ARM Snapdragon, then it doesn't support it because we use Graal native images. So when you download Mill, now it's opt-in. You have to put -native in your version file. Next version is going to be default. You download Mill, you get a native binary that includes Corsair, the dependency resolver, which will then download all the JVM as well as all the dependencies that you need.
Oh, you mean that by default you are distributing as a self-contained executable?
Yes, as a Graal native binary. And that works everywhere except Windows ARM.
Thank you.
So your builds are in Scala. And if you're saying that you've got a Graal native image, how are you loading the builds? Is this just via reflection or?
No, we have this multi-process architecture. So we have a client, we have a server. This is actually very common, like Gradle, Bazel, Maven all have this architecture. You have a lightweight client, you have a kind of heavyweight server on the right here. The heavyweight server has all the class loading and stuff, gets slow, but it starts off slow, but at least it warms up and you keep it alive. And the lightweight client mostly just runs and exits. So if, for example, you look over here, if I do like Mill version, you see it took like 0.1 seconds. Well, this is a Graal native image, starting, connecting to the backend server and exiting. If you look at JPS, you'll see my Mill server main sitting in the background, ready to receive calls, and it gets warm and hot and fast. And that's how you get the fiction of a fast loading command line tool, despite being a JVM. So the first time you run the Mill build, it might be slow. And not just slow in terms of warming up, but also in downloading dependencies, filling cache and stuff. But because we have this long-lived server, it gets fast quite quickly. And then, yeah, and the backend server can do all the stuff that a Graal native image cannot do. For example, Graal native cannot do class loading. So we have to do all the class loading in this backend server. The front-end client is really just a proxy that launches it and bootstraps it.
Cool, thanks.
Hello. Follow-up question from that. So one common issue I have with SBT, like you can run things in the SBT server and whatnot, but I might be working on 2 or 3 projects and I'll end up with 2 or 3 SBT servers, and I have to go and find them and kill them. So does Mill have this? Will Mill have the same problem, or is it just one single server for all the projects?
It will have the same problem. It has one server per repo. The server turns itself off after 30 minutes. You can tweak that number, but basically if you spawn too many, then they'll just be sitting there and you have to turn them off. Yeah. There's a batch mode as well that does not run the server. So it will spawn a new process every time, shut it down when it's done, but then you will pay the warm-up cost, which is usually a few seconds of overhead. So depending on what you want to do, you may want to use that instead.
There are a bunch of build tools like Maven, for instance, where your build configuration is just a boring flat data file like XML or like JSON. And then there are a bunch of build tools like PureScript has Spago, which have DSLs that are a different language, where you're still writing a program to define your build, but it's not a program in the same language that you're actually like writing your program in. Now, Mill uses Scala and SBT uses Scala, and I was wondering if there's like any insight as to if you have any insight as to like why Scala developers like writing their builds in the same language as in Scala, and other developers don't. Like,
So I guess I would question the assumption. For example, according to the latest JetBrains survey, half of Java ecosystem is on Gradle. So the Java developers apparently love Groovy and Kotlin as well, not just Scala developers loving Scala. I think it's really a trade-off that there's no correct answer. You can go either way. If you squeeze your build to be very, very simple, the complexity will go elsewhere. So what often you see is that, oh, you have a build script that's XML, but you'll use a Maven exec plugin to run a bash script, and then the bash script all hell breaks loose. Alternative, you have a build script that's XML, but outside the build script, you would run a run maven.shell script that will set the right properties and profiles for you before running Maven, or maybe run CodeGen first before running Maven. That's also very common. So yeah, if you try to squeeze the complexity too much, it just gets squirts out the side and may end up in the worse state than before. If you use a very confusing DSL, like I think Gradle's DSL is quite a lot worse than Mills. For example, Gradle, you have to manually register all the dependencies. If you register the wrong things fall apart. If you use confusing DSL, also becomes problematic. So everyone's trying to find the right balance, and I don't think there's a right answer. So Bazel, for example, has its own Python-like DSL. It's pure, non-Turing complete Python, but it's still Python, and so has lots of problems. All the standard Python prompts are large code bases, like poor ID support, performance, lack of types, and so on. One thing that we get from Mill that is very nice, one thing Mill gets from Scala that is very nice is the entire toolchain. Like people say Scala is a niche language, but if you compare the Scala tool quality, including IntelliJ and stuff, with the Bazel pseudo Python tool quality, Scala is actually really good. Like with the Bazel Python folks, they spend a few years working on the package registry, for example. Guess what Mill gets for free? We have Maven Central. They're currently working on coming up with a whole new type system for Python. Guess what Mill gets for free? We have a type system, and you have IDEs. Like the people working on the Bazel IDE is probably 10 times as many people that's working on Mill in total. So although Scala is a bit niche, it's still much less niche than all the weird pseudo languages that builds often end up having. And Mill tries to leverage that to its fullest. So there's no Mill IntelliJ plugin. There's no Mill package registry. There's no Mill type system, type checker. There's no Mill compiler. It's a bit weird Scala with a bit of tweaks, but it's by and large Scala, and we can benefit a lot from that when we don't have like an army of Google engineers being paid $500K a year to program for us. Yeah.
good answer, thank you.
Hi. How flexible is it regarding test strategies? For example, I've got a project where some tests depend on a rate limiting resource, so we want those tests to run sequentially whilst keeping the other same tests more or less parallel.
We have a flag you can turn on any task that is exclusive equals true, and they'll run serially. It follows a Bazel, which has the same thing. And yeah, if you want to do it, you can do it. It will run without parallelism, which could be good or bad depending on what you prefer. Yeah. So for example, I think like we have Android experimental Android toolchain here, and all the Android tests run sequentially because we all use a global Android emulator, which is very expensive to set up. So we don't want to keep setting up and tearing them down. So you set them to exclusive, and it generally just works.
Yeah. Thank you very much.
Thank you. Any other questions? Right, I have one last one actually. Sure. It wanted off the question of SPT type level and the adoption of Mill as well. So you mentioned that there aren't that many, I wouldn't say plugins per se, but I guess that would be the analogy, right? Libraries that people would publish to help you. If we were to make the analogy with something like Scala.js, there are lots and lots of Scala.js libraries because it's very easy to cross-publish, right? So I can write code in Scala and with a little bit of plumbing can very easily publish that for Scala.js. Is it possible to do the same thing for plugins with Mill? So I have a SPT plugin and I just write it slightly differently and then get a Mill one.
Yeah, so the basic constraint here is that if you have code that is not coupled to SPT, you can run it in Mill. So for example, earlier we saw Scala tags, but things like Scala tests, Scala format, Scala fix. If you have a jar that just does the thing, you pull into Mill using import IV, and that's end of story, you can use it. If you have code that is heavily coupled to SPT, so SPT plugin logic is mixed in with actual build logic, then you'll need to separate that out to say, here's the pure version, and here's SBT, and the mill can use the pure version. So this is actually not unlike Scala.js. For example, Scala test was very heavily coupled to a JVM, and over time you separated the JVM part of Scala test from the Scala part, and the Scala part could run on Scala.js. So similar for mill, where if you have, I guess, dependency-free jars that do things, mill can use them very easily. If you have dependency-heavy jars that are stuck in SBT, you need to pull them out first into a kind of standalone thing that you can use. Yeah.
Thanks very much.
Cool. I guess we are done. Thank you.